Welcome back to the Geography 300 Geographical Data Analysis video series for WVU. We are now switching from descriptive statistics, which we saw in the last set of videos, moving towards inferential statistics, the other type of statistics that comes up within our analytical process. And this is going to take some laying of groundwork or ground rules, let's say. A lot of them are based upon the ideas of probability. Now, how we use probability to relate one thing or one process to another. This first video in the probability section is just setting out some of the terms that we will often be using as we go through this introduction and understanding of what probability is and how it works. The first thing, and this is to understand that it's all about likelihoods and shades of gray. We have an event. That event has some kind of outcome. So I'll put up very generic definitions here, and I'll fill them in with examples. We can think very simply, an event, anything that happens. Something happened, that's an event. How it took place, how it happened, is the outcome. So we can think of, I've used polling as a previous example. So we could say somebody votes. That is an event. The likelihood that that person, whether we've talked to them or not, the likelihood that that person is a voter for one party or a voter for the other party or a third party entirely is how it happened. Another example to illustrate sometimes events themselves can be very rare, very unusual. An event could be falling out of the top window of a skyscraper. The outcome could then be considered whether you survive the fall or die from the fall. A third example to show something that is where the event itself can be very common, but a very particular outcome is not. Also getting towards a lot of these ideas come from, a lot of probability concepts have been developed basically through gambling. And people working through all of the different permutations and combinations that are available through, say, 5 cards randomly chosen out of a deck of 52. There's your poker hand. The event, when you're playing poker, getting 5 cards is a pretty much guaranteed event. The set of 5 cards in your hand is the outcome. And so you could have an outcome that is a royal flush. Of all of the possible outcomes for that event, that is a perfectly valid outcome. Just extremely unlikely. This idea of likelihood then gets to the frequency of something happening. Again, this is a very generic term. and it might seem weird to you that we're dealing right now with all of these very generic phrases as we're getting towards something that is very precisely defined mathematically. We'll start to get there, don't worry. Or maybe you do worry, depending on your perception and attitude towards math. Anyway, we'll be getting there. The frequency is how often something happens. And you could think of that as, if you're playing poker, you have one hand per round. If you're doing an entire night of poker, you might go through 10 or 20 different rounds, 10 or 20 different hands. And so, at that point, if you think about playing over a lifetime, the frequency of playing over a lifetime can be thousands upon thousands of hands. The frequency of getting a royal flush in that lifetime might be once. The frequency of voting in a presidential election, that happens once every 4 years. And the frequency of a person voting for one party or another over the entire population, we had over 150 million votes, 80-some million for Biden, 70-some million, 74 to 81, I think, millions, about 74 million for Trump. So over the entire country, the frequency of votes for Biden, 81 million, the frequency of votes for Trump, 74 million, the frequency of all votes, somewhere between 155 and 160 million, depending on third parties and so on. The frequency of, we sure hope, the frequency of falling out of the top floor of a skyscraper is incredibly rare. Likewise, the frequency of dying after falling out of a top floor skyscraper window is incredibly rare. Chances are the likelihood of not dying after doing that is almost zero. We will take these frequencies, and you notice in some cases I was getting towards numbers in how often it happens. Those numbers will become very important in this next definition. So now we are actually getting to the probability of something. So in what is called the frequentist approach to statistics, which is what we'll be using here, the frequency of outcome A divided by the frequency of the events that could have led to outcome A. Taking those two items and dividing one by the other. That is your probability, or in a sense, your relative frequency. So if we just took a voter at random from the entire country and just plucked them up and asked, how did you vote? Somewhat over half of the voters, maybe 52%, voted for President Biden. So we would say the probability of a voter supporting Biden within the country would be the frequency of all people who supported Biden. So that number divided by the frequency of the event, which is the total number of votes. So at that point, it's his vote share. Within the skyscraper example, I would say the probability or the frequency of dying after you fall out of a skyscraper divided by the frequency of falling out of the skyscraper in the first place. Those are almost the same. They are both very rare events, but if you have one, it is almost always followed by the other. Therefore, that probability of death, once you fall out of a skyscraper window, is extremely high, almost 100%. On the opposite side, if you are a regular poker player, the frequency that you will get a royal flush is probably higher than the frequency of you falling out of a skyscraper window and dying. But we will consider that probability to be extremely, extremely rare because the event, getting a poker hand, is much more frequent. So it might be twice in your lifetime you get a royal flush, divided by 20,000 poker hands. Now you're looking at 1 out of 10,000, or 0.001%, 0.01%, or 0.00001 as the probability. When we start to get into the next set of terms, excuse me, there is one more concept, one more term here in general ideas from probability. It will come up in the next video as well when we start looking at how the rules of probability work. And that is independence. As I said, we are often using inferential statistics to relate one thing to another. If there is no relationship, they are independent. So if I have a coin, and I flip it twice, if it's a fair coin, the first flip and the second flip are independent. Whether I had heads on the first one tells me nothing, absolutely nothing about whether I will get heads or tails on the second flip. As this moves towards processes, we will now get to a few terms about different kinds of processes. So we are starting with this idea of a process. If we are studying something, we probably are assuming it happened for some reason. There is some interesting geographical process or interesting process going on. We can break these down into a few different kinds of processes. And the first is a process deterministic or probabilistic? Put another way, if a process is deterministic, we can predict it perfectly. There are not a huge number of geographic processes which we would consider truly deterministic. An example would be the amount of sunlight in a day that a place receives. As long as you tell me where that place is and what day it is. So the day of February 28th, 2021 at Morgantown, West Virginia. It is possible to identify, just knowing that location, the latitude, and so on, and be able to tell exactly how many hours, minutes, and seconds between sunrise and sunset. That is deterministic. Most geographic problems, most geographic processes are in the other category, a probabilistic category. That just simply means there is some way in which uncertainty or randomness or probability comes into play when that process is happening. We can break those down into a truly random process or stochastic process. Just as there are very few truly deterministic geographic processes, there are very few truly random processes as well. The random process is one that is purely governed by chance. Thinking about, again, going back to the gambling examples, a coin flip. That should be truly random. No way to know in advance if it's going to land heads or tails. Drawing cards from a deck. If it's truly shuffled, you could get any one of the 52 cards. If you were thinking about rolling dice for a dice game, any one of these 6 values, equally likely. Again, completely random. The stochastic processes are what we encounter most frequently. Those are ones that have some element of randomness, some element of chance, but it's not complete. So the voting, say again, the voting behavior of a person, there are many factors that go into that. Where they live. Somebody who is living in West Virginia is more likely to vote for a Republican candidate for president versus somebody who lives in New York State. Those two have different voting preferences. Income has a role. Education levels. Racial categories. There are many demographic factors that can affect how a person votes. Even knowing all of that, we can never know with certainty, because even then, if you take somebody who is the same age, same education level, same gender, and so on, even I'll just say with me, that other person could just as easily vote differently from me. It's never guaranteed. But there's some information that you can get, and you can make a decent prediction about it. That would be a stochastic process. Likewise, in physical geography, there are factors that govern where a plant can and cannot grow. That can be the soil type, the climate, potentially the aspect, whether it's on a north-facing slope or a south-facing slope, moisture levels. All of those can play a role. Even then, you're not going to be able to predict with 100% accuracy the exact locations of that plant. But by that stochastic process, you have a pretty good idea of where to look anyway. So those are 3 different kinds of processes: deterministic, random, and stochastic. And we saw prior to that, some of the other probability-related terminology, events, outcomes, frequency, and how we use the frequency to define a probability of a particular outcome given its event. As always, if you have questions, please feel free to ask them in the class Zoom session or by email. Thanks for watching.